Thank you guys for coming in. Appreciate it. Jason Wither with AdvizeX. We have 3 sessions today. We've got one on virtual volumes that we're going to talk about now. A Horizon 6 update coming up at 2 o'clock, and then a NSX overview at 2 o'clock as well. So I'll let you guys flip a coin of which one of those two you want to go to. We appreciate you guys coming in today. Just to give you a quick update on who AdvizeX is here in about 30 seconds. AdvizeX is a global company. We're part of Volta. Volta has global resources, and we are part of the Tennessee team. So AdvizeX heritage is in the data center business. So very large VMware partner. We were the global partner of the year last year for software-defined data center. So that's everything that kind of fits into the cloud suite. A couple years before that, we were infrastructure partner of the year. So we do a lot with VMware. We have a lot of consultants that, for us, that is our business. It's our people. It's what makes AdvizeX different. So a couple, who is Volta and who is AdvizeX? Volta is an applications integrator. So you think about SAP, Oracle, database is really on the Volta side. They do a lot of work in enterprise applications. And then AdvizeX is an infrastructure company. So we do consulting and sell product around EMC, HP, Arista, VMware, Microsoft, Cisco, are our biggest OEMs that we support, along with a lot of others. But like I said, the biggest part of our business is our consulting business, and we lead with our technologists. So we've had a great couple of years. The Volta acquisition happened right here. We were a very healthy company before that, but that's really spawned our growth quite a bit. And I guess I already talked about the partners, but again, we hate to brag, but our consultants really are what drive our business and lead us to a number of industry awards every year. So specifically, like I said, around the VMware space, Global Partner of the Year. We do have local consultants that sit here. Eric Wamsley, who's going to present now, is one of our principal consultants out of our Franklin office. He's been with AdvizeX a couple of years, very deep in the VMware business. DJ Gillen in the back, one of our local consultants, does a lot around VMware. Ryan Edwards, local architect, kind of across the space, and the sales reps that are here. Jimmy from Alabama, Brian Shake, who's just here, and Matt Anderson, who's outside. So again, appreciate you guys coming in. This is nothing about AdvizeX from here on out. So Eric, who is going to be presenting very long history in VMware, has DCD, DCA, DC,
DCA, DCD, and just regular DCD.
And the regular DCD. So thanks, Eric, and I appreciate it.
Cool, thanks, Jason.
Yeah, please do make it interactive. We don't want to just sit up here and elaborate. If you have questions, please do ask. So.
Yeah, and I play sports, so if you guys want to throw something at me, whatever, I'll try and dodge it. Dodgeball's my band here. Yeah, so you guys are here for Virtual Volumes. I appreciate you coming in. If you have any questions, something I say doesn't make sense, I stumble over, I start turning red, make fun of me, and then I'll probably get better. So, let's do it. So, my plan here is to talk about Virtual Volumes. We've seen vSphere 6. Hey, it's got all these cool features. vVOLS is one of them. You read blog posts, you read the admin guide. It's really not clear what it is, especially if you've never used it. So, my goal today is to make sure you understand it. I'm going to do it as simple as possible, then I'm going to kind of dive deep. But before we start talking about vVOLS, I'm just going to talk about where we've gone from and where we are today, and then how that's evolved into what we're going to do. And then that'll help understand why it's important what vVOLS is going to do. And I do have 2 videos if we have time, or you guys can say, hey, I'm hungry, and we can peace out. And then, of course, if you have any questions anytime, please stop me. So storage, it always seems to be the one in the corner. It's sexy to the people that admin it. It's pretty cool to say, hey, I've got 500 petabytes of this. I've got this X number of solid state, but it's just disk, just sitting there. You got some lungs. So here's kind of what my data center looks like. I've got a vSphere cluster. I've got a couple VMs, and then I've got my SAN or NAS over on the other side. And then in the middle, somehow they're magically connected. iSCSI, fiber channel over Ethernet, maybe some USB sticks, FireWire, whatever you want to do, and it just kind of works. And then vSphere, they passed out a lot of different technologies, and one of them being like DRS. Hey, I can make a cluster, and now my CPU, I've got a lot of them, but I don't care where my VM is running. It can use any CPU, right? Same thing with memory. I've got all these hosts with 300 gigs of RAM. Well, I've got all these VMs with 8 gigs of RAM, 16 gigs of RAM. I don't care what host they're on, right? It's just this cloud thing. Same thing with networking. We've got these vSwitches. On the back of my physical server, I've got 4 network ports. They're all a gig. But I don't care which one my VM is going out with. It's just a thing. You just say, hey, you're on this VLAN, or hey, you're on this subnet. Just go and do it. You don't have to worry about it, right? You set it up, and it just kind of works. Storage, on the other hand, we've just added some more LUNs. We've added some more mount points. And it doesn't really do anything special. And then, okay, vSphere 5 comes out, 5.1 comes out, 5.5 comes out, and they gave us storage clusters. Yay! But it's just a group of volumes. So again, it's not really, it's cool. You got storage DRS, so you can say, hey, if my capacity on this one volume is high, go ahead and vMotion it over somewhere else. That's cool, because it kind of means I don't have to wake up at 3 o'clock in the morning to, I only have 1 byte left on my volume. Or, hey, there's a lot of activity going on with the SQL server. Let's move some other VMs off, do a storage IO control, so I can do quality of service. It's pretty cool. But again, it's still just volumes. I still got to submit a ticket. I still got to call Bob. I still got to IAM Mark and say, hey, make me a couple more data stores, make them 2 terabytes, make them 4 terabytes. And it's a pain in the butt. So VMware has come out with virtual volumes, otherwise known as vVOLS. And then I actually saw an official VMware announcement that the first V is supposed to be lowercase, but then I literally have read every single blog post, every single admin guide, every single architecture guide, and VMware always puts it as 2 capital V's. So I'm just going to do capital V's because it's fun. Makes me laugh. All right. So we've got vVols. So something's changed here, right? We've got this big data store looking thing, big LUN looking thing. So what is vVols? vVols is your array is the data store, right? So you're no longer taking your array and carving it up. You don't have 50 LUNs. You don't have 50 mount points. You don't have 50 data stores. You log into your vSphere client, you click on data stores, and you have 1. And it's your array. You can have multiple arrays, so then you'll have a couple different data stores. So you have 1 data store. Your data store is the array. The array is the data store. You no longer have VMFS, so you don't go in and say, new data store. I want it to be 2 terabytes. I want you to format VMFS 5, VMFS 4, 1 megabyte block partition, whatever. Your array is the data store. So to kind of talk about how that works, you log into your SAN GUI or your command prompt, and there's going to be a section from your vendor, and whether it's EMC, HP, what have you. You click on the VMware section, and you say, I want a new storage container. So that's actually what we're representing here is a storage container. A storage container is your array, and it's just a conglomerate of configuration options. So if you think about SANs now, you make a LUN and you say, yeah, I want to thin provision this LUN, but this other LUN I don't want to thin provision. So I've got 2 LUNs, 2 different options. So that means when I put a VM on one LUN, it's thin provision. But I put a VM on the other one, it's not. But the array is taking care of all that. And then, hey, I want this one to be deboot. Hey, I want this one to have a replication schedule of every 4 hours. I want this other LUN to be backed up every 2 hours with a retention policy for 2 weeks. With virtual volumes, when you create your storage container, you just say what you want to make. So you want dedupe, you want compression, you want replication, you want backups, you want snapshots at the array level, you want compression, you want unmapping. So if you delete something, you want to reclaim the space. All at the array level. If the array supports it, you can present that through to VMware through what they're calling vendor providers. The vendor provider is just a URL on your SAN that passes API calls. So vCenter goes, hey, this one VM needs to have snapshots done to it every hour. And your SAN or your NAS goes, all right, cool, I support it, let's do it. After you set up your vendor provider, you use, so I'm going to throw some acronyms. You guys have heard of VAAI, vSphere APIs for array integration. That gave us some acceleration. That helped us offload storage calls to the array. Now VMware has vSphere APIs for storage awareness. So VASA. And VASA is used to pass off all those commands to the array. So I say, hey, I need a VM with a 50 gig VMDK. The array goes, done. So it's not, the SXI is no longer saying, hey, write this block, make this thing, encapsulate this. The array just goes ahead and goes, all right, here you go. I got that API call, we're good, green light. And then what VMware has also done is, you may have heard me, I said earlier that you have one data store, which is your storage container. Your storage container is your array. Inside of the array, you no longer go and make volumes. So you don't go to your data stores and say, hey, new data store, VMFS, hey, new data store, NFS, and get it the path. You go in and there's a new option. There's a radio button that says vVol. And you click it, and you just say next, and it's like, hey, I'm talking to this VMX. And is that what you want? You say yes, and it goes, okay. And you actually see a data store. It's about the size of like 8 megabytes. And inside that data store, it's just an encapsulation. It's a virtual data store, and that is a technical term from VMware because it wants you as an administrator to know, hey, I've still got storage, I can still see all my stuff, but really my array is handling it. There's no VMFS or anything like that anymore. So we've offloaded pretty much everything to the array, but then I still have VMs. I need to manage them. So VMware came out with storage policies several years ago, where if you're on your home screen, you'll see this little icon that says storage policies. You probably never clicked it because you had no need to, or maybe you clicked it and you're like, I don't know what this is, so I'm going to ignore it. With storage policies, you can go in and make a policy for all those options we talked about. And I'll go into a little bit deep dive those as well. But VMware calls those storage policy-based management. So you can have a policy for all of your production systems with whatever criteria you have. You can have another one for test dev. You can have another one for HIPAA compliance, another one for PCI. So I love cloud. So this is to make me laugh so I can pause and take a drink of water. So your SAN is no longer ignored, right? It's cloud 2.0 for your software-defined data center. So we've used the acronym of vVOLS, the shorthand of vVOLS. So we have virtual volumes, but I've pretty much said everything except for virtual volumes, right? I talked about storage containers. I talked about your array. I talked about the vendor provider. A vVol is the actual space that your array is using to store things. So on the left side, you'll see that there are 5 different types of vVols. The first one being a data vVol. A data vVol is where your VMDK goes. Only a single VMDK can live in a data vVol. So if you have a VM that has 2 VMDKs, or 2 virtual disks, you'll have 2 vVols. And the reason they do that is for the policies. Once we get dive into the policies, you'll see you get granular control. You can say, hey, I want the first VMDK to be on solid state, the second VMDK to be on regular RAID 6 SATA disk. The next type of vVol is your config. The config vVol is the only one that has multiple types of files that you will use regularly. So your VMX file, which is your configuration file for your VM, will go in here. Your log files go in here. Your NVRAM file goes in here. Snapshot history file goes in there. And anything else like for third-party tools will go in there. Your mem vVol is where snapshots go, but only a single snapshot will go in a single vVol. So if you have 5 snapshots on a VM, you'll have 5 additional vVols. The other vVols are used for, swap. So swap is when your VM is turned on, if it doesn't have dedicated resources, it has a .vswap file, right? So when your VM is powered on and it gets a vSwap assigned to it, it goes in its own vVol. And again, that's so you can say, hey, I really don't want my vSwap to be on 7200 RPM SATA. It needs to be on SSD because otherwise my system is going to be super slow. The other vVol is used for third-party providers. So if you're using Veeam, if you're using something else and it needs to write the data stores, it can go into and have its own vVol. How they use that is up to the vendor. So now, with these 5 types of vVols, there are some limitations. The first is your storage container. So remember, your array can be up to the size of 2 to the 64. I put an exclamation, and I didn't put like those bits, bytes, megabytes, because VMware actually doesn't specify. But if you do the math, you can have a storage container, which is your array, be like 5 or 6 exabytes, or 5 or 6 exabytes. So pretty big. That's if any of you guys have that amount of storage, like raise your hand, because we'll probably be friends in like 5 seconds. That's a lot of storage. A single vVol can be up to 62 terabytes. So that means a snapshot file itself can be up to 62 terabytes. It's a little scary, but you can do it. You can have, right? You can have 5 vDisks. Yeah, exactly. That'd be a nightmare. You may have forgot that. You might want to look at the scripting if you have a 62 terabyte snapshot file. With your VM that has 3 or 4 vDisks on it, each of those can be up to 62 terabytes each. Okay, so right now we've got the limitation of a single vDisk can be 64 terabytes in a traditional VMFS data store, but you're limited to having 256 LUNs or mount points per host. So if I've got all these VMs that need to have a large amount of space, I'm going to be hitting that limit pretty quickly. You'll see that my next bullet says that you can have up to 64,000 vVols. I did the math for you guys. With if you have the maximum amount of VMs on your host, which on vSphere 6 you can have 1,024 VMs on your host, you can have up to 62 vVols per VM. Okay, but if you've got 1,000 VMs on your host, again, raise your hand. That is freaking sick. So we got to be friends. But if you think about it, yeah. All right, actually, I'm going to ask you guys a question because we were talking about VCP and VCAPs a little bit before we started. So when a VM exists, not when it's powered on, just when it's registered inside a vCenter, it has to have 2 files: a .vmx, which is your config, and it has to have a .vmk to have some sort of disk. So there's 2 files. So how many vVols are there when you created the VM? Just blank VM. And I'm not continuing until somebody says the answer, or at least guesses. 2. You are you two. All right. So when you turn on a VM, unless you have dedicated resources, it always creates a vSwap file. A vSwap is a type of a vVol. So you'll have 3 vVols, right? If you add a vDisk, you'll have 4 vVols. If you add a snapshot, you'll have 5. If you turn it off, the vSwap goes away, so you have 4. I actually have a video that shows you this. We'll have a VM powered off, you'll see it has 2. We'll turn it on, it goes to 3. We'll take a couple snapshots, you'll see those increment. And then the last one, you can have up to 256 storage containers per host. The reason for that is you're still using SCSI protocol, or you're still using NFS protocol, and vSphere has a limitation of 256 mount points or 256 LUNs. So when you actually create a storage container and present it to vSphere, you can actually go into your host, click on your storage adapters, and where you would normally see LUNs, you'll still see a single LUN for your storage container. So you'll have that LUN exists, and it's only like 8 megabytes in size. So your limit with the SCSI protocol is 256 LUN IDs. So you can only have 256 storage containers. But if you need 256, that means you have like 256 arrays. So maybe you have a lot of storage. That's pretty sweet. Does anybody have any questions?
How does the storage container count against the path limitation?
Good question. So it's exactly the same as before, which is you can have 16 paths per LUN, I believe. So it's still the same because you still technically have a LUN. In VMware, they use different technology or different wording. Sometimes they put LUN in parentheses. Sometimes they say virtual LUN, but you still do have a LUN. But really, that LUN is just a construct for you to kind of understand it exists.
Are
So
the
you're-
paths determined based on the number of hosts participating in the vVol? Make it up?
Nope, so it still works how you're used to storage now. So if you have a single host and 2 storage controllers, you'll have 2 paths. If you have 2 hosts and 2 storage controllers, you'll still only have 2 paths per host, right? Multi-pathing policy still works, so you can go into your storage storage container, and say, I want to do MRU, or I want to use a fixed policy, or I want to use round robin. So you can still take advantage of that. So let's back up a second again, because this is new, and like I said, I've read all this stuff out there, so I want to kind of hit it again lightly. So remember, right now, we've got LUNs. And in our LUNs, that's where we store all our VM stuff. Here we've got a picture of like a gold data store. Gold data store, maybe that's my solid state, that's my top tier. Maybe I do some replication. When I put that gold VM on it, it is tied to that LUN. It has to have whatever properties that LUN has. So you'll see that with that silver data store down there, which is also a LUN, or an NFS mount, whether I put my silver VM or my bronze VM on that LUN, it still has those policies. So with my silver, if it's auto-tiered and if it's on SATA and nearline SAS, it has to use those. With vVOLs, remember, your array is your data store. So there is no concept of, okay, I've got this 2 terabyte area here is only reserved for these 5 VMs. This 5 terabyte area over here is reserved for my other VMs. Your array is literally your data store. So some of these policies will exist on your storage based on what the OEM provides. So if you have a VNX versus your Viper, you may or may not have something different. If you have an all-flash array, you obviously aren't going to do auto-tiering because you only have one type of disk. Well, these policies are where the strength of vVol, I personally think, lies. So like, for example, with these policies, with caching, you can say, yes, I want to enable caching, or I don't want to allow caching for anything that has this policy. You can even, with some of the vendors, you can say how much cache size they can use. So if you want to say, hey, the VM can only use 4 gigs of cache, and you can lock that down, or you can leave it unlimited. With auto-tiering, do you want to enable auto-tiering or disable it? Do you want to say how often the auto-tiering moves? Some vendors, they have like a scheduled task that runs and says, hey, move SAS to SATA now. Hey, move these 50 blocks up to solid state because it's using all the time. And it only happens once an hour or once a day, so it's really intensive on the storage controllers. For RAID level, you can identify what RAID level you want it to run. So is it going to run on storage with RAID 5, RAID 60, RAID 10, RAID 1, RAID 0? Drive type, again, is it solid state? Is it a 15K, 10 or a 10K? Is it nearline SAS? Is it a SATA drive? Is it a USB stick? Encryption. Do I enforce my VM to have to use encryption, or is encryption disabled? With dedupe, is it enabled or disabled? With compression, is it enabled, disabled, and even with some vendors, what level of compression? Do I want just the fastest whatever compression, or do I want, hey, this is archive data, squeeze that baby down, let's get rid of it. With replication, how often am I replicating data? What's my RPO going to be? Am I replicating stuff every 4 hours, every 6 hours? And remember, this is at the array level. The array controls everything I'm saying. So it's not you going in and saying, hey, vSphere replication, I want you to replicate this stuff every 4 hours. You literally say, hey, this VM has this policy, and it is going to replicate every 5 hours. Snapshots, array-based snapshots, where you can have periodic snapshots. Every hour, take a snapshot of this VM. My retention policy, keep that for 2 days. Every 5 days, take a snapshot, keep that for a week. And also pretty neat with the snapshots, you actually see that in your vSphere window. So So you right click on your VM, go to Snapshot Manager, you'll see the list. The read and write latency, you can set minimum latency requirements and maximum latency requirements. Same thing with I/O. With your read and write I/O, I can say this VM requires to have a minimum of 50 IOPS, and it has a maximum of 10,000 IOPS, so that way you can limit it. Space reclamation. Do I want to force the array to do space reclamation when I do delete tasks? How often do I want that space reclamation to happen? Thick and thin provisioning. What do I want the default format to be? So when I create a VM, you can say I want it thick, eager, thin. Which one of those do I want to default, or do I want to force one of those? Backup policies. This was actually really interesting. There's a lot of documentation out there with the vendors where you can do array-based backups, and you set your policies in your vSphere client. So you say, hey, vSphere client, I want everything that has my policies of financial data to be backed up daily, and according to the government, we have to keep it for 5 years. Hey, I've got this test dev system. It's kind of important, back it up once a day, but keep it for a week, because we don't want to keep all the storage. The next one, quality of service. That's just what it says. Do I want to have this VM be higher priority than this one because it's a file server? This one's just my little wiki about whatever. Then multi-tenancy ties in with a lot of the other VMware scripting. So it ties in with NSX, ties in with the vRealize suite on different tenants. Hey, they're going to get these feature sets. This other tenant gets these feature sets.
Eric,
sir.
virtual copy.
Virtual copy. Oh, I missed that one. Thank you. So virtual copy in the VAAI, if you have an array that is enabled, right, you can right-click on it and say clone, and instead of it being sucked up into my ESX host and then written right back, it just says, hey, Mr. Array, please copy it for me. So it all happens. The storage controller does the copy. It's the same thing in vVOLS. It's a virtual copy because it's not being sucked in and spit back out. Thanks on this stuff. Keeping me honest. So I've talked some examples. I'm going to give you some more because this is something that it took me a while to wrap my head around until I saw some videos that said, hey, so one of them is like, hey, let's create a policy that is around compliance. So again, I'm in the finance sector or I'm in medical, and I've got a policy where I say auto tiering is enabled because I just want good performance. I'm going to let it do it however the array wants, so I'm just going to leave the default of do whenever the script runs, and I don't care how much data goes around. Encryption is required because that's what the government says I have to do. Replication. This data is important, so I want to replicate every 4 hours, or I want to have an RPO of 4 hours. Snapshots. We've had problems with the VM crashing because it's a file server. Okay, or we really have to make sure the integrity of our data is kept. So I'm going to take a snapshot every 2 hours and keep it for 2 days. And then backups. Let's go ahead and back it up daily and keep it for 2 years because that's what's required by law.
What's the mechanism to perform the backup operations? Is it BDP or does it have to be native that's part of vVol?
So it's going to depend on the storage vendor. So that's one of those questions I hate saying, but that is because EMC is going to do it differently than HP versus everybody else. These are all array-based. So if you're using a backup solution that ties into the array, whether it do it snapshot-based or some sort of like Xcopy or something else, they'll tie in with the API calls through the backup provider. It does not go and say, hey, BDP, back it up. You could do that through scripting. So that's where kind of the multi-tenancy comes in, where you say, hey, if I put something in the storage policy, execute this script, which makes BDP do this, makes vSphere replication do this, that kind of thing. So we can do, then we have a performance-based policy, where we go, hey, caching enabled, I want as much data as possible. Auto-tiering disabled, because, hey, maybe I'm going to pin this to solid state, because my next option is my drive type, pin to solid state. Dedupe enabled, compression enabled. the replication, I'll go ahead and set a policy for that. And then this is where it kind of gets really fun. My write latency, my read latency for my performance, let's say my max latency is 5 milliseconds. So the array will work to make sure that any VM given this policy will have a 5-second or better response time. My write and read IOs, hey, I want a minimum of 250. So my storage controller has to maintain at least 250 IO with this with VM for this policy. Let's make it an unlimited, and then backups go ahead and do whatever works for my business. The last one that makes a lot of sense is test dev. I don't want test dev to be in cache, so I tell it, hey, Mr. Array, don't cache anything whatsoever for this policy. Auto tiering, I'll let you go between tier 2 and tier 3, but I don't want you on tier 1 or tier 0. Dedupe, compression, I want to enable that. Replication, disable replication. Even though I'm replicating other things from my other policies, I want everything on this policy to be disabled. Read and write IO, min of 0, because if you're not doing anything, I don't care, since you're test dev. But I'm going to max you out at 150, because I don't want some intern coming in, writing a runaway process, and take down my array, or take down anything, right? Backups, just do it once a day, keep it for a week, right? We know it's a test, you're like, man, I'm not going to have enough time. Now you're like, oh crap, I'm going to go video about this. Yeah, exactly. Turbo boost. So this is, if you ever Google vVOLS, this is probably the first picture you'll see. It's on every blog post, it's on all VMware stuff, it's on Bob Builder website and everything else, right? So again, your array is your data store. Your array is your data store, right? So we're no longer having 50 data stores. We no longer have 250 data stores, which means 250 ones. We have a single one. And I think I'm just going to go. I'm going to pause here for questions. Then I have a video that shows you real quick how to create storage policies. So you'll see that I'm not blowing smoke. There's a drop down that literally says RAID 5, RAID 10.
So I have a question.
Please.
Your array is your data store.
Absolutely.
Is that real? I mean, you have high read-write levels of a database. How do you lump all that together with your other general compute type of machine?
Absolutely. Well, how do you do it now, right?
Well, I mean, so how we do it now is we carve it up.
Sure. So you have maybe 3 or 4 DAEs, one's 10K, one's 15K, one's solid state, or something else such, right? Okay, and that's all going to the same storage controllers?
Yes.
Okay, so when you're making these policies, that's where you go in and say, hey, I want my test dev to never touch my tier 0 DAE. I want it to only be on the DAE that's got the 10K RPM disks, or my nearline, or just my SATA. So when I say your array is your data store, it's because you're no longer making data store, right? Because right now you make a data store and you only put that data store on tier 3. You make this other one, you put it on solid state. Okay, so now vSphere and the array talk together through the vendor provider using the VASA APIs. It says, hey, this VM is being created, it's got these policies. It says it's only allowed 250 IO, period. Hey, it's not allowed auto tier. Hey, it's not allowed solid state.
So does vVol limit? Is vVol the one limiting that, or is it telling the SAN?
That's your SAN, right? So vCenter is not actively monitoring your VMs. It's literally making an API call, it's telling your array, hey array, these VMs have this policy, which means 250 IO, or this bandwidth, or this RAID policy. And then, hey, I change it. I do a vMotion, and I migrate from my solid state tier to my flash tier now, right? So you have a data store 1 underscore SSD, data store 2 underscore SATA. You just right click vMotion, migrate. Now you just edit the VM and you say, hey, storage policy, you're now going from my test dev, and I'm elevating you to solid state, and the array takes care of the migration. So the array takes care of everything. Does that help?
It does help.
Yeah. That's why I don't. it was Albert Einstein or somebody smart once said, like, if you can't explain it in like one sentence, then you don't understand it. So I spent a lot of time, that's why I say the array is your data store. So we're not formatting the array with NFS. Literally, like your data store, right, is just a thing, you just put crap in it. Your array is now a thing, you put stuff in it, and you don't care. Anybody else have? Yes, sir.
So how are you configuring the underlying hardware in the array itself?
Good question.
Say like the DNS, or you just taking all your drives, making one pool, and then the vVol API is then placed in and manipulating?
Yep.
Or is the vVol API itself, you just leave all the disk unused, and then the vVol API itself is configuring and cutting up RAID groups and manipulating the.
So he's asking how on my SAN or my NAS do I say how much storage it can use, what can you use dedupe, can you use compression, things like that? How do you configure that? How do you configure your storage container?
Yeah.
So you go, so in your VNX, I haven't seen the VNX, I've seen the VNXD. You actually log into the VNXD GUI, and there is a section called VMware, okay? So if you have a VNXD array that you bought a month ago, it won't have this unless you install the VASA level firmware. Okay, so this is a new initiative. It's not something that you'll see now. So if you have a 3-part now, it's not going to have it. But 3-part is supported. You have to go to HP's website, download the firmware, and install it on your array, because it is adding functionality to your array. So what you do is you log into your VNXD Unistream, and you say, there's a little button. You click on VMware, and it says, all right, do you want to do traditional ones and data stores? Go ahead and carve that up. Or do you want to create a storage container? You click storage container, and there's a wizard, and it literally asks you, do you want to enable these features? So, am I licensed for compression? Okay, yes. Am I licensed for encryption? No. So, okay, I'm not going to check encryption, right? Same thing with replication. Do I have replication already set up between my arrays? If yes, okay, I'm going to check the box for allow replication. With the VNXC, you can set limits too. So you can say, hey, I don't want some crazy guy going in saying, yeah, you can replicate every 5 minutes, because that's going to kill my WAN rate. But I'm going to set my lower limit to 1 hour and my max limit to 8 hours. And then once you hit OK, you go into VMware, your vSphere client, and you register that vendor provider, which is it's just an HTTPS link to your storage controller, where the API calls go. And it registers with your SAN. And it says, hey, what features do you have available? So when you go to create a storage policy, it's only going to show you things that your SAN admin or you, which I did this, if you're the guy, has allowed. So if you don't allow people to say what RAID level they can do, then it's not going to give that option. Or if your OEM doesn't even provide the functionality to do auto tiering, it's not going to say you want to do auto tiering. Am I up? I don't forget what time it is.
Just about time, whatever.
Okay, I'm done with you.
Well, the next one starts.
Oh, so I got to stop. Well, how about we riot, all right? Let's bar the doors.
So what Jason had offered is you can definitely come by and
Absolutely.
get the questions about this.
Yeah, definitely. Please come by. I'll stand out there and talk about it. Like I said, I've read like every blog post, and like the first 15, they all just took the marketing material, and it's like, hey, it's really cool. It does these like things with the AI, and you're like, what? And then I went around and there's a hands-on lab for it too, and that helps me out. So come check us out, and I'll give you my PDFs, and I've got notes and stuff. But also I can post it on my website. I can post it on Twitter and stuff like that too.
So we're going to shout out your Twitter account.
Yes. There we go. So you feel free to email me, eWamsley at AdvizeX, or just ewams.net, or Twitter eWams, please, and I'd be more than happy.